Okay, so we are recording now, and this is Durwood King with Sampson Community College, and we're having a special session tonight that's going to be talking about the difference between Studio 5000 software and the older RS Logix 500 software. So there are some main key differences, and that's basically all we want to do tonight is talk about what are the differences, because this class is focused on Studio 5000, which is what most things are running on now. Anything new is running on that, but yet there are a lot of PLCs in plants like Smithfield Packing and Hogslat that are still using RS Logix 500 software. PLCs such as Micrologix and Slick 500 PLCs and Slick 503, 504, and 505 processors. Those PLCs are still going to be running for a lot of years, and they use RS Logix 500 software. So we're just going to do some comparisons and let y'all see what the main differences are, so that if you do come across some of those, you would at least know how to go online with one of those PLCs and interpret the logic, mainly the addressing that looks different. And so we'll go ahead and get started. And again, it is being recorded, so anybody that's missing this can go back and watch it and watch it more than one time if they need to. And contact me if you have questions at dking@sampsoncc.edu, and I'll be glad to answer any questions that you may have. Thanks for joining, guys, Victor and Eric. And I know, Victor, you got your hands on these type of controls right now, don't you?
Yes, sir. So far in the plant, 2 of them, one on the processing side and one in the kill.
Mm-hmm. Okay. So the best way to start out with this is this. I'm going to show you with my webcam what a typical Micrologix looks like. And let me get my okay, so right here. Now, so do y'all see that PLC there?
Yes, sir.
Yes.
Now, if I get close to it, you see it says Micrologix 1500.
Yeah.
So Micrologix is a series of or a family of PLCs that starts out with a Micrologix 1000. I think it's the smallest one it may be, and then it goes up to 1100, and I think there's a 1200, there's a 1400, I believe, and here's a 1500. So each one has a different features as far as what kind of inputs. This one has AC inputs, which are 120 volt, as you see in there in the red. And the outputs in the orange are relay outputs that can be wired for AC or DC outputs, depending on the common wire that you hook on the terminals and for the outputs. So, and if you notice that the communication cable there at the bottom right, that's not an Ethernet, that's serial. So what I'll do is I'm going to show you. Let me cut the PLC off. And I'll show you what the jack looks like when you pull it out. So a little bit tricky here with let's see. Let's see if I can move my monitor screen where I can keep losing the view there. Now, I'm going to try my best. The PLC is actually behind my laptop. If you kind of see, let me show you what I'm working with here. You see my laptop?
Yeah.
And then behind it, I've got a big suitcase trainer that's right behind my laptop. I took this from the school. I don't know if any of y'all been in our classroom in the shop.
I have.
No, not yet.
All right, do you see that big suitcase trainer there?
Yeah.
It's got the fans, and it's got the PLC at the bottom, and it's got some solenoids over there, push buttons and all. So these are suitcase portable trainers with a handle on top, and we got 10 of those. And that's what you would have started out with on campus. But since you're starting out at home, you had to start out with Studio 5000 because the emulator that you use, the only emulator that works on Windows 10, which is what most people has, would be the new stuff, would be the Studio 5000. So that's why we started out with that instead of starting out with this. But anyway, if we get down here where this cable is, I'm going to wiggle it like that. It's got a right angle plug on it. And when it comes out, you see that round connector?
Oh yeah.
With a D shape on it. It's a DIN connector. I forget the DIN number, but it's a DIN standard with a flat side on there, so it is keyed. And you can see down in the hole there, that's a serial cable. It's not Ethernet, it's serial. So with PLCs, you have serial, and then you have DH485, and then you've got Ethernet. There are some other cables that, other than that, like Profibus, but you go back in here like this, and again, it's a right angle, so you got to go in there just right with it, and push, wiggle it in like that. And now, so on the other end of that cable, if we come around, y'all see where my hand is now?
Yeah.
Yep.
Now, so this is the other end of the cable that went directly into the PLC. So I'm going to unhook that just for a second. I'm going into a converter. This converter goes from serial in the gray over to USB for the laptop, because laptops nowadays don't have serial connections like here in the gray.
Right.
But if I take that apart, here's what we have. You have a 9-pin serial cable. There's 9 pins on this end. It's a sub D connector, 9-pin serial that does plug into older laptops. Like I've got a laptop that has Windows 7 on it from the school, and that laptop does have a 9-pin serial port that matches this. But this newer Lenovo laptop here, it only has USB ports on the side. It's got some small USB ports. So what I'm having to do here is I'm going from a 9-pin serial to an Allen Bradley. Hold on, let me get my hand steady. It's an Allen Bradley 9300 USB-S converter. So it converts serial to a standard USB. And actually USB is serial. Now I don't know, probably a lot of people don't know that, but this is a 9-pin serial right here. Now I'm going to take it and go back into the adapter, and I got to get my camera kind of wacky here to get it plugged back in. Now, so go back, and I've got that 9-pin going into this Allen Bradley 9-pin serial to USB. Now on this end, say it again.
Derwood, just a quick question. On the converter, does it have to come through Allen Bradley, or can you buy that anywhere?
You can order them. I think different companies. There's other people that make them, and I think you'd be okay. But I happened to get this one when I went to a school. The first school I went to for Allen Bradley, I got the cable and a small PLC that I actually put together and built a little trainer unit myself.
Right.
And it came with that. But I think you can get converters from. I know you can get them from other companies that should work.
Okay, I was just wondering if you had a different one, and with it not being an Allen Bradley, would it still work with the Allen Bradley PLC?
My guess it probably would. I can't guarantee it, but I don't know why it wouldn't.
Okay.
I don't know why it wouldn't. Now, on the other end of this converter here, if you take a look, on this end, Now what we have here is we have a square, and if I can get it unplugged while I'm holding it, this end is a USB type B. On USB you have A and you have B. Now, so on this end, this is called a USB type B that looks kind of it looks like a D on the end. You see that?
Yep.
So this is the end that goes into a printer. So this cable I got in my hand without the adapter is a printer cable. You see what I'm saying? So on this end, this is what goes into your newer printers. It's a USB type B. It goes into this adapter here, into this Allen Bradley adapter, into that squarish looking with a little flat on there. I've got to get the camera kind of wacky to get plugged back in here. I ain't got my two hands here. Now, so again, I've got it plugged back in. So I've got the USB B here going into the adapter, the converter, and then it goes 9-pin serial. Now, just a little history here. USB, do you know what the letters U and S and B means? Anybody, have you ever heard what the letters mean for USB?
I've heard it, but I cannot remember.
Universal Serial Bus. So look, USB is really serial, but it's a universal serial bus. This up here, the 9-pin serial, is called RS-232 serial. That's one of the things you'll see when we have to go pick the driver here in a minute to go online with the PLC. The driver that you got to use for this cable is a RS-232 type driver serial. So what you're doing, you're still going serial out of the laptop. Now on the other end of the USB, it comes down and it lands right here with a USB A. So if I unplug this, that's a standard USB A, right? That's just that's a most common USB. So
yep.
we've gone from the PLC with a serial round DIN connector serial to a RS-232. It's an RS-232 cable. Goes to a 9-pin serial on this end. So it's a 9-pin D connector on this end. It's the little DIN connector on that end. Then you go through the converter that goes regular RS-232, and it starts out as USB, so it goes USB to serial. And USB actually is serial, but it's universal serial bus. Now, when I was in school taking electronics back in from 1984 to 86, I remember when USB was introduced way back in the early 80s. So I remember when it first came out, way back over 30-something years ago. So it is serial. So you're going serial to serial, but you're going universal serial bus to a standard RS-232 serial. So that's just a little history there for you. And to beat all of that, now listen, so we're going serial through this thing, but look at here. Then we're going to take a standard USB and plug it into this box. Now get this, you get a kick out of this. This box is it's made by J5 Create. If I can get my camera back where you can see it. You see the letters J5 Create there?
Uh-huh.
Now this is a hub here. It's a hub that this laptop is a new laptop. The only way I can get into this laptop, it has on the side of it, it has a little small USB-C type jack. You see that little white cable there?
Mm-hmm.
So I've got a box here that I ordered from Walmart, and it has 2 USB-A ports on it. It's got Ethernet. Now this is what I'm talking to you through right now. So I'm doing Zoom through that same box. It's also got HDMI video. So all of them 4 ports are actually being multiplexed through a small little USB-C. And USB-C is the same type of connector that goes into your cell phone. So those of you that have newer cell phones, do you recognize the shape of that jack there, that small one there?
Yes, sir.
That's like a cell phone jack. So what they're doing on these new computers is they're putting like cell phone jacks on here, USB-C. You have a USB-A. This is the A. And then you have the B, which is a square looking one. And then the USB-C is these that are kind of oval looking. And that's what I had to go. That was my option. I had to go out of USB-C and find a hub here that had USB-A's and also had Ethernet, because this laptop does not have an Ethernet port on it. So I've got one over here, one Ethernet port here, and I've got another Ethernet port. I got another hub over here on this side. So this laptop, I'm coming out of this side with a USB-A. It has one USB-A port on the computer. I'm going to a 3-port hub right there that's got 3 more USBs on there. So I'm using one of those for my webcam. I'm using one of them with another Ethernet adapter here, going USB to Ethernet for my PLC. So this one is going up to the PLC, over to the compact Logix with Ethernet. So I've got 2 Ethernet ports coming out of this computer, and both of them are going from USB. But that's the USB-A on the right side of the laptop, going to a hub, and then I'm going out of one USB to a short pigtail that goes Ethernet. The other 2 USBs, one of them is my mouse and the other one is my webcam. So isn't it crazy what I'm having to do? You know, with this little laptop, I'm getting all of that connectivity out of this thing to do what we've been doing. So, you know, I've got the webcam I'm moving around is coming out of that same hub there, and Ethernet for that right there, plus my mouse, because I got to have a real mouse, you know. But anyway, so we're going to plug our serial cable back in here. And by the way, you can get these hubs like this. You can get these hubs for about $60 from Walmart.com, and they work really good. So whatever jacks that you need that you don't have, you know, figure out what available port that you have on your computer, and you can go on Walmart.com and search. And that company J5 Create, they're a good company that has a lot of variety on different port features that you can get coming out of one port, and it will give you a lot of things there. That's a very powerful little box there to give you all of that out of one port, you know. So anyway, so we're gonna set this down here, and let's take a look at how do we get my cables stabilized over here. Now, so we're going to take a look at how do we set up RS links to talk with that PLC through that cable. Okay. So I'm going to set my camera down here so I can type. Now, so I'm going to do a screen share. I see McGill has come on. How you doing, McGill?
What's going on, Durwood?
All right, pretty good, man. How about you?
All right.
Did you catch all of that I was just saying about that serial cable?
Yes, sir.
Okay, good. Great. So you see physically how I went from serial to get into this laptop, into this new laptop that's only got USB-C. So it can be done, and it can
you got a lot.
Do what now?
So you got a lot connected there.
A lot. There's a lot connected there, and I was sure hoping all of it would work, and it did. And I'm thankful that it did work. I was especially concerned, wondering could I do 2 Ethernet ports out of one computer, and you can. When they're going out of different ports, you know, it shows up as different adapters. It's physically different adapters, and then your computer will automatically It'll run them. It'll run them.
Cool.
So anyway, I'm gonna do a screen share. We're gonna go at RS Logix, and our first step is to set up communications with this MicroLogic PLC through by serial. So I'm gonna do a screen share, and let's see. Let's X that out. I got to get you back to my to the desktop. Go back there. Now let's go cross that out. Now, so do you hold on? Let me update again because I know I just lost that. 5,000. Do y'all see my desktop with icons?
Yes, sir.
Yes, sir.
All right, now we're going to go up here to RS Logix Classic. So RS Logix is the same links that we use for Studio 5000. It's just got all the drivers that you need for whatever kind of PLC you're dealing with if it's Allen Bradley. So it's the same links. And do y'all see that link screen there?
Yes, sir.
Now I'm going to delete the driver that I just put in there because I've already set it up a while ago. Yeah. Now, do y'all see my Ethernet driver and then the virtual driver?
Yep.
Yes, sir.
Okay. Now, hold on one second here. PLC back on.
You there, Victor?
His name is still there. Yeah. Is Victor, you still with us?
Yeah.
Okay, good. Now, so very carefully here, what you've been doing in this class so far is you just been doing.
Yeah, hear me?
Yeah.
Oh. Working, man.
Yeah. Okay. So far, what we've done in all the class periods before this is you've been using RS Logix to set up a communication driver through Ethernet to the Compact Logix PLC. Now we're going to do it through serial. So watch real close here. And we can leave these other drivers running here because they're totally separate from serial. So you go under the available driver types and you do drop down. You see all these driver types that are in there?
Yep.
Mm-hmm.
There's a lot of choices in here. I mean, what we're doing is only just a few choices of what there is within RS Logix. So you would choose RS-232 DF1 devices, and that means serial. So they don't say serial, but RS-232 is serial. It's the cable with the 9-pin D connector that I showed you that I took apart from that adapter. That's the RS-232 portion, is that cable. It's the cable that goes directly to the PLC after the adapter. So we click that one, and then we hit Add New. This is the default name of the driver. It's ABDF1-1, and you just leave that name alone. That's what, for some reason, they call it that. And then you hit OK. And then the next step is this. You need to know what port number on the laptop that you're going out of. Now, a while ago, I didn't know what port number I was coming out of because I'm going through a multi-hub port that's coming out of a USB. So I had to, here's what I'm going to show you what the process I went through. So if you don't know what port it is and you got a multi-hub port, here's what you do. I mean, so you can go ahead and hit auto config, but it said unable to open the specified COM port for configuration testing. You see that?
Mm-hmm.
It was unable to do it. So I didn't know what port number it was. So all I did, I went down the list until I found it. I tried COM port 2, auto config. Didn't work. I said, well, I know I'm going to find it. It's going to have to be one of these. COM port 3. That didn't work. It's actually going to be 5, but I'm going to show you what I went through to find it. None of those are working. You hit 5, it's going to work. Now, I wouldn't have known that. I would not have known that because I've got 2 different hubs out here I'm working with. And the first time I tied to this PLC, I think I was going off the other hub, but now I have to go off this hub because I've got the other one full. So it's just a process of going through and trying the different COM ports. And when you hit auto config this time, okay, now hold on, it says not able. Maybe it was 6. And a while ago, I had one of them that worked. Not working. Hold on.
No worky.
Hold on. Let's make sure I got everything plugged in correctly. Because I had it working a while ago.
Hey, Durwood, they'll be calling you. Durwood Maintenance got a copy.
Yeah, go ahead. Right. Yeah, I'm gonna
Worky.
no worky. Let's back it up because a while ago it was 5 that worked. You see it? I had to unplug the cable. I unplugged the cable to the adapter and reseated it. So it turned out to be COM port 5, but I wouldn't have known. There was no way for me to know which one it was because on that hub, they're not labeled, you know.
Right.
And from the computer standpoint, depending on which USB port on the computer you plugged into, that's going to also change the port numbers that are on that hub too. So if it doesn't work the first time, you go down to the list until you find one, and you'll find the one that works. So it configured itself at COM port 5 with a baud rate of 19,200. That's bits per second. And then it knows that it's a micro Logix controller by that device up there. So it figures all that out. And it set up the protocol and the error checking and all that stuff. So that was good there. Okay, so we hit OK. And it says that the driver's running. We can hit close. And the next thing you want to do is go over here under the DF1 driver and expand it with the plus symbol. And do y'all see where it shows the laptop and it shows a MicroLogic 1500?
Mm-hmm.
Yep.
So the driver does see it. That's what you want to do before you exit out of links, is you want to make sure links does see it. And,
I got a question, Mr. Durwood.
Yes, sir.
Can you go back to your available driver types?
Go into configure drivers. Yep.
Mm-hmm.
And go under here.
Mm-hmm.
Uh-huh.
Now, EH. Hold on.
You take your time. We got plenty of time. This you guys are
What does it mean by the DH 485? I kind of remember some I did over there by the Singer on the kill floor, and I chose one of them. Now auto configure it and it communicated. I didn't think I choose the RS 232.
Right. It's Data Highway 485. It's a different protocol.
Okay.
DH is.
Will it work though? Did it work?
Huh?
Victor used that one. I mean, it worked, right? Apparently.
Yeah, but the type of cable that the type of cable you use, what kind of cable was it?
Same as yours. That go to the MicroLogics. Same same communication style. But I didn't have a USB adapter. That's an old laptop, so I had to put it where it goes from that serial cable.
So you had a 9-pin serial port on the laptop?
Yeah.
Okay. I know.
I don't remember for sure, but it was something about a DH.
DH 485. I know. I can. Let me just show you something here. Here's something I've got here that is DH 485.
All right.
You see the PowerFlex drive I have right there, the VFD.
Yeah.
Now this one, if you go up inside there, you see that connector right there. Let's see if I can get a little more room here. I've actually got some cables tangled up here. Let me get the camera. I've got to move the camera around a little bit, get my spaghetti untangled here. Yeah. Okay, so here.
Yeah, the way.
That looks like Ethernet, doesn't it?
Yeah.
Oh, okay.
But it's a DH485 connector.
So okay, so
that's not Ethernet. It looks kind of like it, but it's not. It's different.
okay.
The protocol's different.
So what I probably did without even put an available driver type. Oh no, they probably had it saved up in the computer. I'll try to look at it tomorrow.
Right.
But I went in there and put auto configure in it, and it got the serial cable. But I'll take a look at
it. The DH485 has got a different.
Because right now you're in the AV on your left side of your screen. ABDF1-1, comma DH485.
Yeah, it does say that on there. It does.
Oh, okay. So I must have chose the right one, but it said that.
Yeah, it does say it up there. It says it up there, but I know that down here in the blue, that's a different cable. That's where I think that's for a different kind of cable. I believe it is a 1784, which is not a MicroLogic. It's some other PLC or drive. I'm not sure what that 1784 is.
Okay.
I've never used it. I don't know.
Maybe that's where I'm getting confused, because I saw that on the left corner.
Right. You saw the DH485 up there.
Yeah.
Okay. But, and I'm not sure. I don't know why. I guess that that's a good question why that's in there. But I just know that the cable itself I'm using is a RS232 type cable.
So that's a cable for MicroLogic, right?
Yeah, that's a cable for MicroLogic. Yeah, it's the one with the little round end connector.
Yes, sir.
You may have some MicroLogics that's got a different connector that that's possible there.
I use the same connector. You got the small round one. That goes in there. Yeah.
Yeah. So, the DH485, we could do a quick little investigation into the meaning of it, and I know it has to do. There's a difference in the way that it handshakes when it communicates with what it's communicating with. I think the handshake protocol is a little more involved when it with what it's communicating with when it's DH485. But the DH means data highway with Allen Bradley.
No, some reason I like the 5000 better. When you straight hook to it, it'll show up there.
Right. Yeah, but again, if you got some of these controls in your plant, then
yeah.
It's if you want to know it now this is the stuff I work with this stuff for 20 solid years. So this is what I was used to all the time. So anyway, so that's and there's other drivers in there. A plain Ethernet driver would be for panel view. So when you go directly to a panel view to set one up initially to actually write your panel view program, you use the ordinary Ethernet device's driver, not the IP driver.
So right now I'm getting confused. So for a 5000, if you use straight hooking up to it, you don't have to choose the available driver types. For me, it just popped up on the left side of the screen.
In other words, whenever you plug the cable in, it pops up.
Yeah.
Okay.
On the RS Logix, right? For a 5000, like the connection, like a printer cable connection.
Well, I haven't noticed it doing that. I know I have to do. I know what I've always done is I've had to go in there and set it up manually because of.
Which one do you choose for the 5000?
Ethernet IP driver.
Okay.
Yeah,
But if you're not using Ethernet though, I understand that's for the Ethernet.
I'm going USB to Ethernet. I mean,
Yeah,
not with this PLC, not with this PLC, but for our regular class, I'm using Ethernet, of course, you know.
yeah, but if you don't want to use the Ethernet part and you just hook up to the main processor, like the kind of like the cable that looks like a printer cable.
Right. Yeah, the front. In other words, you would go through the USB.
Yeah.
The regular, yeah, the USB B, that orange one there.
So you will go to available driver types and
Well, no, that's the automatic driver there.
yeah, that's what I was talking about.
Yeah,
Yeah,
that driver pops up automatic there.
Yeah. Okay.
Yeah. The one that you plug into initially when you first get a brand new PLC is
it
the
automatically pops in.
USB. It automatically pops up. That one right there does. But the Ethernet is one that you manually configure that.
Yeah, I understand that part.
Yep. And I don't know why. Anyway, it's just one of them things to where they've got it set up to where it does. It's a plug and play driver for USB-B for the front port. I guess maybe they did that to get you going quicker, you know.
Yeah,
could be. Okay, so do y'all have any questions about how to set that driver up?
No.
I know there's another driver I used way back, and it was a PIC driver, and it was for a Slick 500. It was a PIC driver. And let's see, is it still in here? PCIC. I don't even see it in here. They may not even have it now. That may be so old what I was working with. I was thinking. Anyway, the way I'm remembered it with the older Slick 500 PLC, I don't even see the driver in here that I used to use. But used to, we had.
Only I see is a PCIC.
PCIC, yeah. And I don't know. I know that the box I went through, you came out of an old laptop, and you went through a gray box. It was a big old plastic box, and it was called a PIC box. And then you go out of that and you go into a Slick 500 port, which is with a DH485 large connector, like looks like the one kind of like on the PowerFlex. It was a larger connection with a little clip on it. And so you had to go from a computer through this plastic box, and it was called a PIC box. But this is a lot of years ago, and I don't see the driver on it, unless it may have been that one. Maybe I don't remember it being that one. I know the box itself was a PIC box, but I guess it could have been. It's been a bunch of years ago since I've had to use that one. But anyway, and then you got other stuff. The virtual is what you use with your emulator.
Yeah.
And then you got DeviceNet. DeviceNet is something that's kind of being phased out. It's not used much now. Ethernet's pretty much causing DeviceNet to be a thing of the past, kind of.
Right.
And then you've got SmartGuard. SmartGuard, that's a different driver for some of your hardware that y'all might have at your plant. And then remote devices via Links Gateway. I'm not sure what all that would do, but anyway, there's a lot of stuff in there.
So the ones we need basically for basic is the RS-232 DF1 devices and the Ethernet IP driver.
Yeah, Yeah, but if you're going to do panel views, if you set panel views up, if you're creating panel view programs, then it would be Ethernet devices driver. Yeah, okay. They're different. Those two are different. You know.
All right.
Now, once the panel view program is created and you got it in there, and then you network it with your PLC and everything else, then then you're going to be using the regular IP driver there to communicate with your system. But if you go straight to that panel view to do editing to it, It's the Ethernet device's driver. It's what I had to use on the panel view I have. So,
Okay.
all right. Any other questions, guys, about it? And then before we move on.
No, sir.
No, sir.
Okay. So we X'd that out, and that driver's working right. And then I'm going to minimize that. And then we go to RS Logix 500. So, 500 up here, English. So, do y'all see my desktop?
Yes, sir. Sir.
Okay. So double click that. Okay. Do y'all see that screen there?
Yes, sir.
Yes, sir.
Yep.
So the best way to learn it would be to create a little program, and we're going to create one that does the 3 motor starters with the timers. And that way you can see how do you do the addresses for inputs, outputs, timers, and we can actually add a counter in there too, so you can see how the counters are done too. And that'll cover a lot just in one program. So we go to the new icon, which is in the same place as it is in Studio. You see that? It says new.
Mm-hmm.
You click that, and then you go through, and you're going to pick out which PLC it is. And so the PLC that we're dealing with here is, and I wished I'd done this before I want you to actually see how this PLC comes out, so you can see how part number and all that. So we're going to actually back up a step here. I'm going to cut the PLC off. And I'll show you how to identify the part number of the processor itself. So do you see the PLC now?
Yeah.
Yes, sir.
So you see that little catch thing right there? You pull that out. You pull that out like that. That's a lock device. And then we're going to slide the whole front out. The CPU is actually a part. The CPU can come out of that main frame there. What you've got is you have a PLC with fixed inputs and outputs with no additional modules. It has 12 inputs and 12 outputs. But the CPU can slide out this way, and then we can see the part number, the catalog number, once we get the CPU out. So let me move something here so I can do that. And hopefully, let me get where I can see this on a large screen. Yeah, that's better. So from this point of view right here, what you do is once you pull back that lock and you unlock it, you have released the CPU to be able to come out. So you see where that little crack is right there? The actual CPU is going to slide out of the main frame. And the easiest way to do it is to put your thumb on the back here, and then take your hand like that and pull. And it really takes both hands to do it. So I'm going to set the camera down. See if I can get it where you can actually see me do it. Now, so real carefully here. Had to move my teeth. So I'm taking my thumbs. I'm try to get. I'm going to put one hand here, and slide back. So you see what I did? I'm sliding that out.
Uh-huh.
I'm sliding the processor out. So it comes out of that side right there. So this is the brain right here. That's the CPU. That's the brain. The rest of it is the input and output section with the power supply built in. So if something goes wrong with this PLC, if you have an input to fail, you can't fix it. You got to replace the whole chassis there, or the whole brick there. But the CPU, it can be pulled out and saved. Now, on the back of the CPU, you would jot that information down. It's a MicroLogic 1500 processor, catalog 1764 LSP Series C. Y'all see that?
Yes, sir.
So this is the information you got to have whenever you create a program. 1764 LSP Series C. And then the firmware is 11, but you don't really have to have that. It's just the main thing is catalog number series. You see those little connectors on the side?
Yes.
They go inside there into that port internally in there like that. Can y'all make that out?
Yes, sir.
Now you have to very carefully, you'll slide that thing back into a tongue and groove set there and go back in really easy. And then you want to push and hear it click. Now, when you get that snap right there, that little release, it actually locks itself back, and then you're good to go. And you make sure that there's no cracks in there, that it's all fully engaged, that you heard a good click. Everybody good with that?
Yes, sir.
Yes, sir.
Also, the front of this pulls off too. You can grip the front of this and wiggle and look carefully. You can wiggle the front of it, and the front comes off, and there's a permanent lithium battery in there that's soldered in. You can't take it out. And then there's a place in here for another one. If this thing is gonna have power out for a long period of time, you buy a lithium battery with a pigtail in there, and you snap it into here, and then you plug it into a connector. Hold on. I'm trying to remember at the plant which give me just a second here. Okay, this connection here for the main front of it for the display, it goes in right in there. So the other one, and I didn't remember it being that way. Hold on, let's go back into here. That, okay, that one goes into there. The battery has got a really small connector. I've got to lay this thing down here so you can see something here. Oh, okay, it's under there. Now, do you see under there? It's been some years since I have had to do this on one of these. At the plant, okay, you see, you see that small connector right there? It's just up under the big one.
Mm-hmm.
Yeah.
It's got 3 pins in it, right there. You see those 3 pins?
Yes, sir.
That's the battery connector for the battery that goes up in that clip right there. So this is a place that you put if you're going to have if you want long-term battery backup. You buy a lithium battery. It pops into here. It's got a short pigtail, and it plugs into that connector right up under there with them 3 pins. See that? So it'll be a battery that looks like that. It'll be a 1/2 AA. It's the AA diameter battery. It's a 3.6 volt lithium battery with a pigtail. It snaps into there, and it goes into a pigtail that plugs into there. And so that if you were going to have if you needed long-term storage, that's what you would do there. Okay. Do you know Victor or McGill? Do y'all have? Do you see anybody going around putting batteries in any of these?
No, not yet.
Okay, and so the display, you know, it plugs into right back up into here. So we go back in place like that, and it snaps in place like that. Okay, so that's on this particular model. That's the way it works. Now on other MicroLogix, then on smaller MicroLogix, if you have a 1000, not a 1500, but a 1000, it doesn't even have a display on it at all, so it's different. Okay, so it just depends on what level, what model number that you're dealing with. So anyway, so that's how you get the part number off of the processor. Is you really got to go into it like that. Now I'm going to plug the power back in, and we'll set communications up and write this little program and then run it.
Oh.
Yeah, PLCs like this is what we had that were running. A little small PLC like that, we had them running really big presses. I couldn't believe it the first time I saw them. I said, you mean they're going to trust that little PLC on that humongous press? I was just seeing big old PLC 5 cards that were huge mods of really robust PLCs back in the late 80s and early 90s. And they started coming out with the slicks and the MicroLogix, and I said, man, I shook my head when I saw them. But they work and they last. So that's all I can tell you. That they're actually good. They're small and kind of lightweight, but they perform. They really perform good. I was surprised. So anyway, let's go back to our screen. Yeah, I came along. My history goes all the way back to PLC 2. So PLC 2 was before the 5. So I come into the thing. It was PLC 2s, and then I saw the 5s come in, and then the 500s and MicroLogix, and now the 5000. So I've been watching this stuff since '88. So
Wow.
Yeah. Okay, so now we go down and we're gonna pick the right CPU, and which should be a 1764 MicroLogix 1500 LSP Series C. Right there. So if you notice with the MicroLogix, you got 1500s, you got 1400s, 1200s, 1100s, and 1000. And I see one right here, Victor. Look down there. It says that's a different kind of MicroLogix. Yeah, and it has a data highway 485 D8 slave or whatever that is. I've never seen that. But see that there are different, variations on MicroLogix. Ours is a 1764, and that's a 1761. And that could be older. I'm not sure. But anyway, that's the one we want right there. You hit OK.
You want C? You hit B.
Oh, I hit B. We better go back. So for controller properties, let's right click. Hold on. Hold on. Let's go back. You can change the controller type. I sure did. If you make a boo-boo like I did and didn't even know it, now what it would have done is when we went to download, it would have told me that there was something wrong, and then it would have given an option that it would automatically fix it if I give it permission. So yeah, you were sharp seeing that. So it is a Series C we got to go to. LSP Series C. I see there's an LRP. Some of these have DC inputs. This actually has 120 volt AC inputs and relay outputs. So we go there and hit apply. Confirm processor type change, and say yeah. And hit OK, and that's good. So at this point, what it's done is it's given us a ladder logic window to create logic. And it looks kind of like in Studio 5000, but it's simple. There's not as much to this. So let's start out by, let me show you what I've got wired back here. So up here, I've got a push button for start, and I've got a stop button. Y'all see those buttons on the trainer there?
Yep.
So this trainer, it's a big old suitcase trainer with a handle on it. And it's got buttons and stuff built in there with some terminal blocks. And, you know, they're pre-wired into there. You just put your wires into there and you go to the PLC. So I've got power going into the top one from down here at the bottom. My power source, I've got it going up to the top of that button. I've got 120 volts going here. I've also got it jumping to the stop button, and then I leave the stop button here, and I'm going to input 0 that goes into the input section. And then the start button, I'm leaving it here, and I'm going to input 1. Now these terminals here that I'm wired to up top here, they go down into, if I open the door up on that MicroLogic, you open the door up, then you can actually see the, cut there. Let's go back to large screen just for a second here. So do y'all see the terminal layout there?
Yes, sir.
So for instance, input 0 is going down to here, and you see where that blue wire is. And down here, it says not used in I/0 is I input 0. You can actually see where that wire's coming from there, going up to that second terminal on the bottom row. That's the input 0. So this stuff is actually on the fold down door that you can tell by the labelings, how do you wire, or if you're measuring voltage coming in for troubleshooting purposes, you can read right there on that label what's what. And then the second one I have for the start button, you know, it's coming down to the third terminal on the top row, which is I/1, which is input 1. You know, there's other things in there, common wires that are jumped. We won't take time to get into all of that tonight, but each section in here, it tells you where the commons have to go. And there's an AC common there. There's one there. And there's another one. So to cover all 12 inputs, you have to have 3 commons hooked up, and I've got them jumped. If you see that, they're jumped here to here to here. And that covers all of the input groups that are there. And so that's something that would be unique for each type PLC. You got to put commons on wherever it's asking for them, you know, or hots. For the inputs, these sections have to have some commons in there, and then you're bringing hots in for each point. So the outputs also has it has a door down there that opens up, and that's kind of fuzzy looking there, but you can kind of see what it's showing you down there. You sort of make that out. It's fuzzy looking, but can you see it?
Yeah.
So you can make out there that you have an L1 on the bottom left. That's from power. L2 is neutral. Then there's ground, and then O/0 is output 0. O/1 output 1, and O/2 is output 2. And that's what we're using on the orange wires. We have output 0, 1, and 2. And they're already connected up. Those large terminals are connected to the PLC. And also another thing is up top, if you notice above, like here you have output 0. You see that? That's going to be for the first starter. Now that one gets its power from VAC 0. So you got to put 120 volts on that. This is a relay output. So you put 120 volt on that terminal, and then when the output comes on, it gets power from that terminal and connects it to here. This output 1 gets power from VAC1 or VDC1. You can put AC or DC on that terminal, and whatever's here appears right there whenever the output gets energized by the processor. And this output here, it gets power from that leg. So you've got a jumper power to all of these VAC terminals so that the individual relays can have power to draw from. So that's like an open contact there, and it goes, that stays hot. And then when your program turns output 2 on, it connects VAC2 to output 2. And that's how the power legs are hooked up. So all that stuff is already hooked up within there with some little jumpers and stuff in there that you can't hardly see. But just keep in mind that you've got to satisfy the requirements of each PLC, and it's going to be different. You know, for all the outputs, anywhere where it says VAC or VDC, you physically got to put a hot leg there of whatever voltage level you want to appear on the output, whether it be a DC signal or whether it be an AC signal. You know, and for here, the VAC 0 is just for that. VAC 1 is just for this. VAC 2 is for here. VAC 3 is for here. And once you get beyond that, then look at here. VAC 4. Can you read that?
Yeah.
Yeah.
The VAC 4, get this now, it supplies power for a whole group. So that one hot terminal, you see how the shade, the color of this is, the way it's shaded, it's a lighter color. So VAC 4 supplies power for output 4, 5, 6, and 7. And then VAC 5, which is fuzzy, VAC 5, it supplies power to 8, 9, 10, and 11. So whatever power you connect here on VAC 5, that's what you're going to get at these 4 outputs when you turn them on individually. So they are individually controlled in the program, but they get power source from that one terminal. But you could put AC on this one and have a group of AC outputs. You could put DC on this one and have a group of DC outputs. Everything before it has their own individual power leg. And I don't know why in the world they designed it that way, but that's just what it is, you know, on this model, on that particular type of MicroLogic. And so there are jumpers up in there that jumper a 120 volt to every one of the VAC terminals. Every one of them that say VAC has got 120 on them already. That had to be put in. And you can't really see all that in there because of how dark and fuzzy it is. My camera can't really, you really can't get a good view. You see some of those jumpers that are up in there, way up in there?
Yeah.
They're small. They're very small, really small. But anyway, okay, enough of that. And I figured that might help you. Is that new information to y'all? Or had you
Oh yeah.
It is? Okay. Okay, good.
Yeah, all this is new for me.
Okay, good. So that's now, but the good news is this, is if you ever had one of these go bad, if you ever had the CPU can be slid out, of course, and you can put another one in. But if you ever had enough inputs or outputs to go bad that you didn't have any spares available and you had to replace the whole chassis, the good news is that you can loosen a screw, that bottom left one there. You see it right there where my finger is? You loosen this one and loosen that top right one back in there.
It comes out.
Yeah, if you loosen that one and that one right there, the whole strip comes out. So that whole strip, then you can wiggle it and get the whole thing out with the wires attached, and you don't have to unwire anything.
Oh wow!
So all those jumpers that are in there, you can leave them where they are, and don't unwire anything. You just you unscrew the 2 extreme screws on the left and right, and you wiggle the whole strip and pull it, and it's a quick connect. So the whole thing comes out.
Now is that the same thing for the output too?
Same thing on the bottom end. Same thing. You can see the screws. That of course, you don't see the light. You don't have much light in there. but there are, let's try to put a little light on the subject there. Let me change flashlights here. You can kind of make it out. Let's see. Let's see. You see it back in there?
Yeah, I see it back in there now.
You got one in there. And then over here, you got one. This is tricky here trying to do it with a, let's see. I'm trying. There it goes. You see it back in there? Back in that black hole?
Mm-hmm.
It's back in there, right in there in that corner, that black corner. Right back in there. So those two will drop that whole strip out. And you would basically just fold, you know, you could let it all kind of fold down real easy. And if you're real easy with it, then you shouldn't lose any wires. But take a picture of everything before you undo anything, get you some good pictures. And that's always a good idea before you get into something like this. And hopefully the wires would be labeled with wire numbers, but you don't always get that luxury of having wire numbers on everything. Whoever wired it, if they were in a hurry, then they may not have took time to actually put numbers on the wires. So pictures are good. So your next thing would be, you go back to, okay, so do you see the logic screen now?
Yeah.
Okay. So we're going to set up a stop button, start button, holding contact, and we're going to do 3 starters, okay? And we're going to do basically like we did on the 5000, but just a little bit simpler. We're not going to do overloads because on this trainer, if you notice here, they don't have motor starters on here, but they got solenoids. If you see that right there?
Sir.
Got solenoids on there. They're going to take the place of motor starters. So that's like solenoids like on a starter on your car. You know, it's just a regular coil with an armature. We're going to turn those on. So we got solenoids we can turn on. We got fans. And you know, we got stuff like that. It doesn't have motor starters on this trainer, so we're not going to have overloads to be programming or wiring in. So anyway, the stop button is wired into input 0. Now, one thing about the addresses here would be that when all of the inputs and outputs are actually built into the PLC, the inputs and outputs are considered to be in slot 0 when you're dealing with a micro Logix, not slot 1 like on compact Logix. On compact Logix that you've been writing logic for, the embedded I/O is in slot 1. In a micro Logix, the embedded I/O built into the main unit of the PLC is called slot 0. So here's how you. What was your question?
Oh, no. I was just saying.
Mm-hmm. Now, so we go up top, and the toolbar looks the same way. I'm going to get an examine on, and here there's no tags. Now, this is one of the main differences between Studio 5000 and the RS Logix 500 is they don't use a tag system. So your information, instead of it being tags and being in a tags folder, just watch how you do it. So here we're going to double click, and you've got to manually type in I, the letter I, and then a colon, and then after the colon you put down what slot is it in. Is it in slot 0, 1, 2, 3 in the PLC? Here it's in slot 0 because with a micro Logix, the embedded I/O built in is slot 0. but that changes with the 5,000, as y'all know. But this is one difference. So you got to put a 0 there. Whatever comes after the colon tells you what slot it is. And then you put a /, and then you put the actual input number that's in that slot, which is going to be input 0. So it's I for input, and then colon, and then 0 means slot 0 / input 0 in slot 0. And when you hit enter, then you put the description in. So they don't call them tags, and they're not tags, they're descriptions. Okay, so here we're going to say stop PB. And then we hit OK. And so this is the address. It's not local. They don't call it local. They just say I. It's input slot 0, point 0 and slot 0. And this information, instead of it being in a tag folder, all of your inputs are going to be stored. Do you see where my mouse is waving at now?
Yep.
It says data file output. So the output data file is O0. When you go into there, all of the outputs are stored. Inputs. I'm sorry, inputs. These are inputs. So file number I1 is where all the inputs are. So this is your data table or data file where all of the inputs are. If you notice down here at the bottom for description, it says stop push button for this one.
Mm-hmm.
Okay. Now let's go and add a start button, and you will see the start button also show up in here. So instead of there being a tag folder, there's no tag folder, there's no tags, but there's a data file. Now this is like a filing cabinet, the picture filing cabinet, that the top filing cabinet is O0, which is all of the outputs are in file drawer 0. The next drawer down in the filing cabinet is going to be file drawer number 1, and that's where all the inputs are. The next drawer is S2 for status bits of the processor. And then the next one is for internal binary bits that you use for internal relays. And then all the timers are stored in timer file 4, folder 4. The counters are in folder C5, and then so on. There's a file drawer or folder where all of your data is stored in separate compartments. And this is the main difference between Studio 5000 and RS Logix 500 is you have data files where everything is stored, not tag folder. So does everybody see that?
Yes, sir.
Yes, sir.
So whether you're working with a MicroLogix or a Slick 500 or any of those in those families, in the MicroLogix family or the Slick family, they're all using this 500 software, and they all have a data file section which is where all of your outputs are stored, inputs, all of your timers and counters, all those are really stored out here in that data file section. And that's where you go to view things in a larger view. Now let's get us a start button. And it's going to be I, and then slot 0 / 1. And that's input 1 is for the start button. And then you put a description in. Start push button. And then now I want you to see where that showed up down in here in your input data file. This is your binary representation of all your inputs here. So for input 0, it's labeled as stop push button. You see that? Y'all see that where it's highlighted in blue? That's for the stop push button. Now, if I come over to here, input 1, what does it say? Start push button.
Yep.
So this is where your binary information is stored at. It's in your data file I1, binary. BIN is binary input. So this is where you would go to view. If you want to see all of them kind of in one shot, you can see everything there, all your inputs. And then what we want to do now is we want to have a timer and an output. Well, we want to have an output first and then a timer. So the outputs are going to be output 0, 1, and 2 for those solenoids. So we choose an output. Now, why is it being kind of cantankerous on me? That was weird how it did that. So here, you would put the letter O, and you got to be careful to put a letter in there, not a number 0. It has to be a letter O, and it's going to be nice and round. Colon, and then it's going to be slot 0 because it's built into the PLC. This is embedded outputs, not individual slot, not an add-on slot. And this / and it's actually output 0 in the output section. I'll show you on the webcam where this information is coming from. So let's cut this here off just for a second. So do you see for the inputs, AC inputs, you have, let's back it up some. For the inputs, you see input 0, input 1, input 2, and so on. And then for the outputs, you have also output 0, output 1, and so on. You see those? So there is input 0 through 12 and output 0 through 12. This built in. This is considered to be slot 0 on this PLC, slot 0. If you wanted to add on more slots, you can. You can take that end cap terminator off and slide that off like that. And you can actually add some more modules on there like we did up here. So you can actually make this same PLC here to be modular. Right now it's called it has what was your question? I didn't know if somebody had a question, but this is called fixed I/O or fixed input output because you can't change them. But you can take that cap off and you can add modules like we did up here. You know, the compact logic, it's got fixed I/O in here, but then it has places that you can add on by taking the end cap off. Okay, so that's how the numbers, where I'm getting the numbers from. Okay. Now we'll go back to the logic, and this won't take long here. Does this information, is it helping you? Is it clicking with you pretty good?
Yeah.
It will be better if you had your hands on it, but this is the best we can do. You can still get the gist of what there's really only two main differences between Studio 5000 and then RS Logix 500. And the first major difference is you have data files where everything is stored in separate compartments, not in a tag folder. That's the #1 difference, you know. And then the other the other thing is how the addresses look and how do you specify the addresses. Those are the two differences. Those are two main differences that matter to you. This is output slot 0, output 0 and slot 0, and we hit enter. And then you put, we're going to say motor starter 1, even though it's a solenoid. And you hit OK. And then we're going to put a timer in parallel with that. Now here's where you're going to get to see why is a timer area called T4. Now watch this. If I click in T4, right now there's only one timer in there, but it's going to keep adding them as I add them. But all the timers are going to be called T4 colon something. So the first timer is called T4 colon 0. The next one that you create will be T4 colon 1, T4 colon 2. And you can do like 255 timers in there. You can do, you know, a bunch of timers. So, but every one of them are called T4 colon and then the timer number after that. And the T4 comes from the actual data file that they're stored in. So that's why they have to be called T4. And it shows you the bits that are in there, the time base, the preset, and the accumulated that are stored in there. In there. So we'll take a look at that in just a second. So now we're going to create in the same way that you did. We're going to get a branch. So we go up here and get a branch, and we go around it. So it's the way you write the logic is the same way. You already know how to do it. You just need to learn how to actually put the addresses in manually, and then the right kind of protocol for that. And we're going to do a timer. So timer, it's the same thing as 5,000. You hit TON, but now this is where it's different. We're not going to right click and hit new tag. We're going to double left click, and we have to actually manually say what timer it's going to be. So it's timer T4:0. You have to know that by going in that timer folder. What are the options? And that it's T4, it's timer 0. So if I hit that, I'm going to give it a name, and I'm going to say delay for starter 2. Now here, this is another difference on the timers. In Studio 5000, the time base or the increments that the timer's counting in is fixed in milliseconds. So you can't change it in 5000 as far as the increments that the timer counts in. Here, you can pick 1 and it'll be a 1 second timer. You can pick 0.01 and it'll be 100th of a second increments, or 0.001 and that's in milliseconds. So if you choose that, then it's going to be just like Studio 5000. Okay, the time base is actually selectable in here. But if you do that and you wanted to have a 5-second delay, you would have to say 5,000, because 5,000 times that will give you 5 seconds. That makes sense?
Yeah.
Okay, so just for the heck of it, I'm just going to leave it that way. And if I was going to say 5 seconds, I would say 5,000. Okay, but you don't have to do that. You can go in there and change that to 1 second time base, and go in here and just go and just put 5, and that's it. So if you're going to be in seconds, if you're not going to be in any fine increment, some timers that they have to be in small increments because everything is so split second precise on some machines. But here we don't need that, so we're going to leave it in 1 second. Okay, and then on the next run, we're going to pick up the done bit for this. Well, actually, we got to have a holding contact. So the start button, we're going to do a branch, and go around there, and I'm going to let you tell me. It's going to be an examine on, of course. Now,
yeah.
What do we need to have here for a holding contact?
Motor starter.
Right. We could say motor starter 1. Okay, we can do that. So what's the address?
Wouldn't it be I02?
What if you're going to have the holding contact to be controlled off of that right there?
Oh no, yeah, it would have to be the same.
The same.
Oh. It had to be the same.
Which would be O, and then 0/0, and when I hit enter, it actually picks the same name that I.
Oh wow.
Here. You see how that popped up?
That's neat. Yeah, that's neat.
Yep. That's in the database.
That does make it a little easier.
Mm-hmm. Okay, so we've got that. We've got a holding contact, and now when that timer finishes, we've got to come down here and get us another examine on. And this time, we want to use the done bit off of that timer. So here's how you do it. You say T4:0, and then /DN. So it's the T40 timer that's up here, and it's the done bit. So you put the timer number and a slash, and then the bit number, which is done, right there. And then we don't have to add another label because it's going to use the same label as the timer.
Right.
Okay. And then we're going to let our second starter come on, which is we're going to be another output. This will be output 1, O, and then 0 / what?
1.
1. And then it's going to ask us for a name. And we're going to say motor starter 2. And then we're going to have another timer in here, right?
Yep.
To delay for the next one. So we go in timer counter and we have, wait a minute. I did that wrong. I should have done a branch. I hit undo. We're going to do a branch and then a timer. So branch and then another timer. See, all this stuff up here looks the same, doesn't it?
Yeah.
All of your instructions look the same. I mean, they are the same.
Yeah.
And then tell me, how do I pick the next timer? What do I...
Oh, it had to be a T5.
No, it's.
So you got to go.
They all have to say T4, and then what after that?
Oh, 1.
1.
1.
Right. And then this is going to be delay for starter 3. And then the time base, we can just pick 1 second. And then the preset can be 5, and then you're done there. So that's T4:1. Now, at this point, if I go over to here, you see where I'm going over to the left over here?
Uh-huh.
Now watch, when I go into there, let's hit save. That should have showed up there. Let's hit save. Let's give it a name, and we're going to say DK sequence control 3 starters. And let's see if the timer showed up now. Hold on. That one didn't show up for some reason. Let's see what's going on here. Let's X that out. Let's do a verify up top here. Verify. There was no errors, and let's hit save.
Is it because you didn't? Well, no.
Let's see if it shows up now. Now it did. See, I had to hit the verify and get rid of the E's. Look, the little E's that were over here, and I was still in edit mode. It was not really finalized.
Okay.
But see now, you see how I can float that around and move that around like that?
Yeah.
So this is where the timers are stored at. There's T4:0 for delay for 2, T4:1. Now where I worked at, we had a powder coating section, kind of like y'all do at Hog Slat, and there were like 200 or something. Well, there was probably 150 timers in that system.
Right.
And it was T4:0 through T4:155 or something or other like that. But there was a timer that was for every little intricate thing going on in that powder coating system, for cylinders and timing of doors opening and closing, and it was a lot of timers in there, and they're all software timers that are not physical timers, so they're all called T4 something. Okay. And now finally we want to go down here and put. Tell me, what do I put next? I want to have the next one to turn on the 3rd starter. So what do I do now?
Use the same address? No.
Right. We're going to choose what kind of contactor we're going to choose.
Oh.
No, examine on.
Examine on or examine if closed, what they call that.
Okay.
And now we want this to be controlled by that done bit over there, right?
Yes.
So
you got to do T4. T4. Nope, not Z. That'd be 1.
1.
T4:1 dash
1.
You put a forward slash and then what?
DN
DN.
or
DN.
DN.
Yeah.
I mean.
Perfect for done. And then I'm not going to add
just-
any description there because it'll pick it up from here.
Right.
So this is that done bit is coming from over here.
Right.
And then lastly, we want to have an output for that starter. So
Right.
choose an output. Now, what's the address going to be here? Now, this one was output 1.
This be 2.
Okay. So tell me everything to put in.
0.
The letter 0, the number.
I meant to say O. I meant to say O. Colon 0.
0.
2.
Forward slash and 2.
Forward slash 2.
And this is going to be, you got to give it a name. So we're going to say
motor starter 3.
Motor starter 3. That's it.
Okay.
And then you see the E's over there. The E's, we're in edit mode. We're going to go up to verify. There's 2 verifies. You can verify the routine or verify the file or the whole project, which means you can have more than one file in here. If you got a large machine and you got different files in there for different sections of the machine, then you can verify this one file or verify the whole project by hitting there.
Okay, now I got a question.
Okay.
Oh, never mind. That's just showing. The Bull 1764 is just showing where it's the file, right?
1764. Where are you reading that?
Right there under the outputs.
Under the output.
See where it
Yeah.
says BUL.1764?
Yeah,
that's just showing what module it's in, right?
It is. It's a 1764 output. That's a Bulletin 1764 type PLC output.
That's pretty neat. It shows that. Because the
shows
5000 don't.
Right. The inputs also
And
show.
it did that. Yeah, I see that now. The only ones that don't is the DNs.
Right. They're internal.
And your timers. Yeah.
All of your internal bits like that, that's kind of like base tags in 5000. Things that don't have real physical addresses are called they're internal, and they have it's like base tags in Studio 5000. Okay. So we got a complete program there, and we're ready to download. So you got motor starter 1, and then there's a delay. Motor starter 2, there's a delay, and then 3. So how do we download this thing?
You go to that communication.
Okay.
Go to who active.
That says who active, go online. You want to stretch that out some?
Click on that Ethernet.
Right. Let's go over this way. Now, we're not going through Ethernet this time. We're going through the serial, through the ABDF1.
Okay, I got you.
Yeah, we're not. Yeah, so what we want to do is highlight what do we want to go online with. So if we just click
MicroLogic.
we're clicking on the MicroLogix.
Okay.
And then we can just say okay. We're not dealing with Ethernet, and it's a whole different. It's just different. Okay. You're dealing with what we call point to point. You're going from a laptop straight to a PLC with no other addresses in there. There's no IP addresses with serial. You have they call node address. NODE is a node or a point. It's a network, but it's a serial. It's a point-to-point network type thing, to where Address 00 is node 0, that's the laptop, and node 1 is the PLC. But they don't use IP addresses with serial. So we do that and we hit OK. And actually what we want to do, we've actually got to download, right? We want to download. We don't want to go online. You got to download first. You can't just say
you can't. You go back to it and just hit download.
You got to download. So if you go under, you can go. If you go under here, you would just say download.
Okay.
And it says, or do you want to proceed? So this part is simpler on serial, being that there's with Ethernet, you're typically going to have a lot of things to choose from, a lot of IP addresses in a plant, and you got to be dead sure you got to point to the right IP because there's going to be a lot of things networked together. With serial PLCs, you don't have that PLC tied to anything else. It's just a standalone thing, and you can't monitor it from anywhere else unless you got an adapter. Okay, and so we're online. You see that one thing I like about 500 is the ladder rotates. You see the ladder rotating around?
Yeah,
I kind of like that. And so now, if I hit the start button, ain't nothing happening. You got any idea why?
You're not in run mode?
Not in run mode. Now, actually, when I try to go to run mode, look what it says.
Key switch is currently in program. Change key switch to remote or run to continue.
Now, so here goes another lesson here. We go back to the webcam. Let me now you see that little door right over there. You pop that thing open, and there's a switch in there.
Oh, that's
a 3-position switch. Now, can you read where it says run and then REM for remote and then PROG?
I can't read it.
Yeah, well, we know what you're talking about.
Yeah.
Let's get a little bit of light on there. How about now?
Yeah, I can see a little bit better now.
How about that?
Yes, sir.
Run, remote, and program. Now I've actually got it way over to the right. If you can see that little black switch in there.
Yeah.
I've got it way over that way. So what I'm going to do is, that's kind of like a little dip switch. So I'm going to use something plastic, non-conductive. I got a pencil with the lead retracted. You don't want to have anything lead in there or anything metal in there. So you can take that
key in there, Mr. Durwood.
Huh?
Stick your key in there.
It's not a key. It's actually a switch. They're calling that a key. It's not a physical key like on some PLCs. Now, if I go all the way to the left, it's going to be in hard, what they call hard run. Center position is in remote. When you're in remote, then you're able to change the modes from the laptop. You're able to go switch from run to program from the laptop if you leave this switch in remote. If you put the switch all the way to the right in program, it's called hard program, and you cannot change it. You can't get it out of program from the laptop. So I'm going to leave it in remote in the middle position.
Okay.
This functions like a key switch, okay? It functions just like a key switch. Now I'll show you a PLC that does have a key switch. Well, hold on here. If you go back to the compact Logix, then it also has a switch. You see that?
Yep.
Yes, sir.
So it's got a little toggle switch that's a 3-position for run, remote, and program. Now I'm going to drop the camera just for a second here. I'm going to show you one that's got a key in it. I've got a older compact, I've got an older compact Logix. It's actually got a key. So some of these do have physical keys on them. All right, so do you see that key switch there?
Yes, sir.
You actually put a real key in there in that one. And you actually switch it. There's three positions. So that's got a real key in that one. This is compact Logix. It uses a Studio 5000, but it's an older version. And it's also, if you notice here, it's got Ethernet, but it's also got serial. See that? This is before they put USB on them. So that's got a 9-pin serial port to set it up first. You go in through that serial to set the Ethernet up, and then you just run off the Ethernet. But they dropped doing the 9-pin serial on the newer ones, and they went to a USB serial to configure the Ethernet. So this is the first PLC I ever built. Right here, I went to a Rockwell school, and I got this as a kit, and came home and wired the buttons and wired everything up. It's a little suitcase model that's got a lid and everything. And so this is something the first one that I built back in 2012, I believe. So it's also got a battery in it. When you take this out, there's a lithium battery in here, to where the newer ones have got built-in flash memory that don't have to have a battery. That's got a lithium battery in that one.
Cool.
Yeah. So that just shows you how they're improving them. Okay, so so where were we at? We were, go back to, okay, so do you see up here in the green now where it says remote run?
Yep.
Yes.
Now, I want you to watch that. Now watch closely what's going to happen. I want you to look at the screen up here where it says remote run, and then look in my little webcam, and I want you to see what happens when I flip that switch. I'm going to flip it to the left. What does it say now?
The key switch currently in program.
Now, I don't mean in the middle there. What does it say up here at the where's my mouse at? Up here in this window at the top left, what does it say?
Run, remote run.
It says run. Yeah. Now look up there. You keep your eyes on that window, and watch me hit that switch. What does it say now?
Remote run.
Now I'm going to flip it to program. You see it go to program?
Yep.
Now, you see my hand? I'm actually physically moving that switch. Now, when I'm in program like this, I can't change it unless I go to the PLC and actually flip that switch. So I'm going to put it back in remote, in the middle, in remote program, and leave it that way. Now, in production, you probably don't want to do that. You probably want to put it in run and leave it that way. And if there's a key, actually pull the key out and go hide the key, so nobody can mess with it unless they got a key. But anyway, so that's the position of your mode of, that's the mode of the PLC. It can be in 3 different modes. So when you're in remote, you're able to actually switch to run from the laptop. Now it says, do you want to change the run? And now we're in remote run, and you have a green power leg here. You see that, and you also have the ladder turning, and you're in run mode now. So can everybody see that good?
Yes, sir.
So now let's kind of zoom out where you can see everything. All right, so you can see the whole thing now, right?
Yep.
Yeah, it's about
Okay.
2.
So I'm going to bring the camera over and focus it on the solenoids. So you got 3. Let's see if I can get it where you can see all 3 of those. Yeah. So over in here, you'll hear it really loud. They're loud. The 3 solenoids are going to kick in one at a time. And here, I'm going to hit the start button over here. I did that, and then the first one went in. There went the second one. Okay, so you see how all 3 of those came in like that, one at a time?
Yes, sir.
Hey, Durwood.
Yes, sir.
I knocked off, so I don't know what happened. My computer just went haywire on me. I had to reboot everything back up. So I don't know what you just did.
Well, your computer went out.
Yeah, mine just like whacked out for a minute. It started making weird sounds, and then all of a sudden, I couldn't do nothing. I had to power it down.
Okay, so are you seeing everything now?
Yeah, now I am.
Okay, now, so if you take a look at the program, and you can see also the webcam. The first one is instant, and then you see the timer timing. And then the second one came on, it's timing for the last one there.
All right.
See that?
Yep.
Okay. Now, so let's hit stop. I'm going over here, hit stop, and it cut all of them off. Now, so one thing that you can take a look at is those timers that are in there. If I go in here and look, well let's take a look at the inputs first. When you look at the input data table, do you see input 1 is on, input 0 is on now?
Yep.
You have a 1. Now, if I press the stop button, you see it goes to 0.
Yep.
I let go of it, it becomes a 1. Now, if you take a look over here and input 1, that's restart button. When I press it, it's going to go to a 1. Now watch it. It's going to go to 1, and now I let go of it, and it went away. You see that?
Yes, sir.
So this shows you the binary inputs, all of them in one view. So that's where your inputs are stored at. And then let's take a look at the outputs. If you go into outputs, this is showing you output 0 and 1 and 2. See that, how they're all 1s?
Yep.
So this is where you go to view all of your outputs, would be in the output data file, which is data file 0. Now, if I hit stop, you'll see all those go to 0. I did that. Now I'm going to hit start, and you watch the binary bits in there go true. There went 1. Then you watch the next one. There it went. You see it going 0 to 1. Y'all see all that?
Yes, sir.
So that's how all of your outputs are viewable from that one table there, or that one data file. Your timers, they're viewable from right in there. So let's watch them. You're going to see your accumulated values change. Now watch it. I'm going to 0 it out, and you watch your bits and you watch your accumulators. You see your accumulators go to 0, ACC.
Yeah.
They went to 0. Now watch them. I'm going to hit start again. You see it counting?
Yeah.
And then the next one starts counting. Cool. And so that's all of your timers are viewable within there. You may have you can have up to 255 timers in there. Counters are going to be stored in C5. So if you want to see quickly how a counter could come into play here. Do you guys want to see that, or well, let me see. Do you have any questions right now?
The only thing, because I got kicked out when right before you loaded the program? How'd you go do?
I think he missed out on the like the little the little switch that you got inside to remember we couldn't get it to run because it was in a program.
So did you miss that on that 3-position switch, Eric?
Yeah, I missed that.
Okay, all right. So we go back. If you look, do you see up here in this window where it says remote run?
Yes, sir.
Now look at that window there and then watch the webcam. So you go over here to the PLC, open up that little door there. I'm going to flip that switch to the left. That switch way over to the left there. Now what does it say on the computer screen now?
Run.
Now I flip that little switch to the left, all the way to the left. Go back in the middle. What does it say now?
Remote run.
Now I'm going to put it all the way to the right.
Program.
Right. In program mode, it's not going to actually go into run mode, and you can't switch it from the laptop. You got to put this physical switch in the center position, or all the way to the left. I can actually go all the way to the left and keep it in what they call hard run. But if I leave it in hard run,
remote.
Say it again.
It says remote program. It says remote program right now.
Remote program, right? But listen, when it's in remote, now you watch closely here. It's in remote. The switch, that switch is in the center position in remote. Now watch. I can go up here and I can actually go to run. And then it's going to go to remote run. So when you put the switch position into center position, you can go from remote run to remote program without actually flipping the switch. So you don't have to.
Oh wow!
If you put the switch in the center position, then you can actually toggle the switch from the laptop.
Okay.
Okay. And it's the same way. It's the same way on the compact Logix. If you leave that in the center position, you can also change from run to program from the computer.
Okay.
It's the same thing. It's the same exact thing. It's absolutely no difference whatsoever.
Okay.
Yeah. The whole purpose of the center position REM remote is so that you can actually flip the switch from the laptop. You can toggle You can toggle from program to run from the laptop if you leave it in the center position in remote. It actually causes the switch to be a remote controlled switch. That's what it does.
Right.
Yeah, that's what that's all about. You know. That makes sense?
Yes, sir.
Yep. Yes, sir.
Okay, so
that's pretty easy to remember.
Yeah, it is. It is, and I haven't really mentioned that to y'all in the regular class sessions, and I don't know why I haven't. I know one reason why, because I haven't lectured out of the book any. It's in the book. It's in the book, but I'm telling you, if people don't take time to read that book and read them chapters, it's impossible for me to lecture enough like I do when I got 16 weeks to teach it. If I got 16 weeks, then I'm going to be lecturing. You know what I mean? But the way they've cut this thing down, and it was out of my control as far as the number of hours. There's no way for me to explain everything. It's impossible. So you really got to read. You really got to read it, and I don't mean just look for the answers for the worksheet. I mean read every word, every word in the chapter, every word. Don't miss anything. And it's anyway. So there's a lot to it. I want to teach a level 2 PLC class. I've worked on. I've got part of it developed, but I have never finished developing it, and then I don't have it. There's not really. If someone would teach the basic electrical classes in my place, I could move on to just focus on more advanced classes. So, classes like Intro to Electricity and Residential, if it was, now Carla's teaching residential this semester in a daytime, and I'm also teaching it at night. So we're offering a residential in two selections in the same semester, which is not common. But if, say for instance, if she were to be teaching, say, that one, and I didn't have to do it one semester, then I could finish developing a PLC, a level 2 PLC class to do more advanced stuff, but I've got to have free room in my schedule to do it. You know what I mean? So,
right.
But she learned residential from me. She took it from me like 3 years ago, and she did so well at it that Barney uses her in construction to do their version of it. But actually, this semester she's going to actually teach the industrial. It'll apply for industrial also. The full version, like what I'm doing, she's going to be doing it also in the daytime for early college people, the people that can't come at night. And I'm doing it at night. I'm doing it at night for guys like you that can't come in the day. So
right.
I'll be there.
If you counters would be in, say, C5. So I'll just show you.
Right.
Do you want to see an example of that, or you guys tell me? Do you? Victor, I know you had questions about. Well, he's not even with us, is he?
I think we lost Victor. He might have the same problem. I don't know.
Yeah, let's find out what's going on with him. He wanted to know something about internal bits in that binary file, that B3 binary file. He had questions about that because he's got programs out there that are using internal relays in the PLC that are not physical, and that's in that's in the B3 file, and I can show him some of that if we can get him back. Hold on, we got Dylan Ivy says he's unable to get into Moodle.
I was having problems with that too. First thing, it kept telling me it wouldn't even let me log in for a minute. I don't know if it's something with Moodle tonight or what.
Well, I couldn't get in. I couldn't get in the normal way. I had to go in through my Moodle at Samson CC. You got to go in through. You remember those direct links that I showed y'all?
Yeah.
So let me send that to him. Probably too late now though. Try direct Moodle link. I'm sending him the direct My Moodle link. I wasn't able to get into Moodle directly today or yesterday, which means that they're working on it at school. They must be working on it.
Oh, it is probably that semi-semester they're getting ready for.
Mm-hmm. Yeah. So it's called the direct link is mymoodle.samsoncc.edu. And that'll
when is the last day of school?
Well, for our class, it'll be next Tuesday, which will be July 7th.
Yeah,
okay. So that'll be the last day, right?
For this class, but the last day of classes would be that Wednesday, the 8th, for some classes. Some classes would end on the 8th.
Yeah, because Carla told us we got till the 7th to have everything turned in.
Right, it's the same. It's the same one. It's the 7th. The 7th would be the last day.
So when will we start our next class?
It'll be August. Hold on.
I heard the 17th, but I don't know how true that is.
Yeah, I can tell you real quick here. Mine starts on a Tuesday, which would be. Yeah, the semester officially starts on the 17th.
Okay.
But when I'm teaching is a Tuesday, Thursday class, it'll be the 18th.
Are you teaching
August,
the one at
right?
12 o'clock?
I'm teaching that one. I'm also teaching the one at 6 o'clock.
I'll be there. I'll be at both, I guess.
Yeah. I got you signed up for. Is that McGill talking there? Yeah.
Yes,
I
sir.
got you signed up for both of them. You and Victor too.
I have another question.
Okay.
When is the deadline to turn in the money for that?
You have to let me
To
look
pay
that
for
up.
the classes.
I'm calling Victor right now to see if we can get him back. If he's having the same problem, then he may not know about the direct link. He may not be remembering.
Yeah.
He probably went night.
Yeah, he may have.
Automated voice messaging system. 91058093336 is not available. The mailbox is full and cannot accept any messages at this time. Goodbye.
I'm going to send him the picture of that link just in case. Okay. So I'm
you said Moodle will be reopening on August 17th for us?
Yeah, for the new classes.
Yeah. I just want to make sure it's August 17th, not July 17th.
No.
Get a little break.
Yeah, I've actually got a new class starting for continuing ed. That'll be a remote class for electrical 1, for Con Ed, for continuing ed, and Butterball.
Mm-hmm.
But it's going to be a Zoom class at night that'll go from July 18 to September something or other. And each Monday night it'll be a Monday night class for 4 hours, and I'll be using live Zoom for that. But it's going to be a Butterball electrical 1 class. It'll be for them if they can do it, plus the general public. Just through continuing ed. Those credits don't apply in your degree or your electrical certificate. It's a separate thing through continuing ed. There's a certificate involved in it, but it's not. Well, it goes on your transcript. I'll say that it's not a certificate. It's registered on your transcript that you took it.
Right.
Anyway, so let's see who else somebody had emailed me. Okay, I see programs that come from McGill and from Victor. All right, we'll so do y'all have any questions at this point?
No, not really.
Okay. Now for Victor had a question about internal bits that are not physical inputs and not physical outputs. That would be like base tags in the 5000.
Okay.
So those, whenever you use those, you don't create a tag. You actually use one of the B3 binary bits. And if I double click in there, you see the binary file, and it has B30/0/0, 0/1, 0/2. Do you see how I'm clicking through those?
Yes, sir.
Now, so he was showing me some logic that was on, I forget what machine it was the other day. He copied the program. He showed me a picture of a program, and he wanted me to help him understand how it worked from your plant. And it was using some internal logic like that was not physical. Now, so I'll just show you basically, you know, how it would look. Okay. So let's go offline here. Plus, I'll throw a counter in there, and then I'll do an internal binary bit. Okay, and then show you how that could be tied into here. So we'll go offline. Do y'all? I mean, I'm going to do it for basically because I know for a fact he wants to know how this works, and he'll probably watch the recording. So we're going to go offline by going in here where it says remote run and hit go offline. And so we're just viewing the program now on the laptop. We're not connected to the PLC now physically. I mean, not with, you know, software wise. So let's say, for instance, that let's see what would be a good example of. I'm going to modify the program, and this is going to be just something just to show you how it could be done. Not that you would, but it could be done this way. Now, instead of using the physical output over here, instead of going straight to the physical output, let's say, for instance, I wanted to just show you what a B3 internal relay would look like. So here, I would go in there and change that, and I'm going to say B3:0/0. And I'm going to say internal relay 1. So it's not going to go. Do y'all see what I just did there?
Yeah.
Now, for that, I'm going to go and change this here also.
I called them. She went to the gym when 11 o'clock later, so I think her dad said they would be there and get there about 12 o'clock. So we're around 12 o'clock.
Excuse that. That's the answering machine. I'm back here in the bedroom, and you know. All right. Loud. So do you see how I changed the address on the output and the holding contact? Now, this is not particularly the way you would do it in this program. It's not the simplest way, but I'm just going to show you how an internal would look. Now, let's say, for instance, that you may have a lot of stuff going on in the program that you want internal logic going on before a real output actually happens. Okay. Let's say, for instance, that you for some reason that you wanted it to go through internal logic for however many functions that you did and then go to a real output. So then here, I'm going to add a run. That was wrong there. Let's go here. Pin run. Now, if I wanted that output to turn on a real output, but to do it from within the program, and again, you wouldn't do it just for something that's small like this. The B3 relays that are built into the PLC would be for more elaborate functions than what we're doing right here. Okay, but just so you'll see how it's actually addressed, then this is the way it would be done. So then you would use that same output there, the B3:00.
This time it'd be a 2, wouldn't it? I mean a 1.
And now when that internal relay comes on, that contact's going to come on, and now I'm going to turn on a real output. Not that you would, but you could. Okay. So now I'm going to go back to the regular output that we had there, and then I'll verify it, and then save. So it would not be practical to use the internal relay to do this, and it's just another rung you've got to write, okay? But all I'm doing, I'm just showing you how does the internal relay look. And if it says B3 on there, it's not a physical output. It's actually stored in the B3 binary file right here. You see there, when I open that up, it says internal relay 1.
Yep.
Now, so you can have a lot of them in there. You can have even more than that. And there are programs at Smithfield Packard and a lot of plants that use internal logic to do functions before a real output is ever wanted to be turned on. Okay. And not that there's no point in me trying to elaborate on that. All you want to see is when you see an address that says B3 anything, you simply know that it's an internal relay in the program that's not a physical relay. It's not a physical output. Does that make sense?
Yeah.
And you can see lots of them in there. McGill, get Victor to show you the program that he showed me the other day. And there were several B3 bits in there that were used to do a function before a real output come on. So it's for doing intermediate, in between logic that's happening within the PLC to come up with some function. And then later on, then you want a real output to come on after you do some certain logic functions. So that's just a simple.
Okay. I'll get with him tomorrow.
Yeah, he could show you, and he could actually do a screen share with us and let us see a real routine, a real program, and we can explain to you how it works using the B3 bits in there that are internal. Just know that you've got internal relays in the PLC that you can use, and it's just like using base tags with 5000. It's just internal functions that you can use that are not real world inputs or outputs. Okay.
Right.
Now, I'll throw a counter in there, and then we'll let you see it run, and I think that'll probably be enough. So if I wanted to count how many times this whole thing had cycled, I can simply go down to the end of this and put a counter in there, right? I can go in there and say count up. Now here, instead of giving it a tag, I've got to call it C5 something. So all the counters, and there can be like 255 of them, I'm going to say C5 colon, and the first one is going to be 0. And I'm going to say cycle count. It's going to tell me how many times that this machine has cycled. Okay, and then I may say that after it's cycled so many times, to turn a light on to say it's time to do something on the machine. Okay, so you can actually go by cycle counts, and I may say here, I could just say maybe 3, like that. So I'm going to count it to 3, and then there's going to be a done bit come on, and then I can have a light come on, for instance. If I was going to turn the light on, I'd go in here and do a contact. And if I want that contact to come on when this here is done, what would I do here? I'm going to use C50 and done. So how would I type that in?
C5 colon, then wouldn't it be 1?
Well, you got to use the 0 because it's the first counter.
Oh yeah, because
first counter is C50. The next one will be C51, C52, C53. Like
okay.
the timers are T41. I mean, the timers are T40 and T41.
T41. Okay.
Right.
I see what you're saying now.
Mm-hmm. Yeah. Yeah. So if you were going to do more than one counter, you could go in there and but after this you would say slash and say DN. And I'm not going to add any more description to it. It's for cycle count. But just know that will be the first counter. If you added more counters, it would say C51, C52, You see in there where you would have room for more.
Right.
So if you had multiple counters, it would be listed as 0 and 1 and 2 and so on, but all of them will say C5 in the beginning. And okay, and then we could, you know, turn the light on. And well, instead of turning the light on, I'm going to do an internal thing here because I don't have another light wired up. Or I can turn the physical output on that's not wired. I can do that. But if I wanted to, well, there's no point in doing the internal relay. Let's just do a real physical output. We have the next output would be output 3. So if I were going to do output 3, what would it be? A physical output.
Oh, colon.
Yeah.
0.
Yeah. / and then 3. We use output
Okay.
0, 1, and 2 on the starters, and output 3 will be the next one. And we can just say service light. Yeah. Even though I don't have one wired, it's still going to turn the output on. And you wouldn't, 3 is not a practical number there, but I'm just going to show you how it would do that and how a counter would look. You know, and if you had more than one counter in there, if you throwed, say, you know, 2 more counters in there, if you went here and said, put another counter in there, actually, I'm going to go in there and change C5 2. What shall I call it? And then for this counter, it's going to be, I'm going to call it C5 0. C5 0. And preset. I'm just going to throw some numbers in there. This is not anything real that you would do. And I'm going to change that label there by right-clicking and hitting edit description. Starter 1. Count. It's just going to count how many times starter 1 comes on. Not a practical thing, but I'm just going to show you how it can be done. So if you go there, I can right-click and say extend branch down and put another counter in there, and then we'll call it a wrap. This counter would be C5 1, and it would be starter 2 count. How many times starter 2 triggers? And it would. This is not a practical thing to be doing. I'm just showing you how the counters would look and how they would look in there. So you got counter number C5 0, counter C5 1, and counter C5 2. You see that?
Yes, sir.
Y'all see that?
Yep.
Yep.
Hello?
Yeah.
Sir.
Can you hear us?
Everybody there?
Yeah.
Hello?
I'm here.
Can you hear me?
Miguel, you hear me?
Yeah, I hear you.
Miguel, you hear me?
I don't hear anybody talking.
It must be him.
Yeah, I can hear you. I can hear him too.
Hello?
Can you hear me?
Hold on. I think my speakers are muted. Hold on a minute.
I just text them and let them know.
Yeah, I seen that.
Yeah, my sound got cut off.
Can you hear us?
Yeah, my
Got us now?
yeah, my microphone, my speakers got muted. I'm sorry. Yeah, I don't know how that happened, but it got muted. I'm sorry about that.
That's all right.
Okay, we ain't gonna linger on this, but do you see how I put those other counters in? It's just gonna count the strokes on how many times that it does it, so you can see what it looks like. Got 3 counters in there, and that's not a practical thing you would be doing, but it's just a way for you to see some counters. Okay, so we'll hit.
All right.
And it says in rung 3, there's an error, invalid output instruction position in rung 3. Okay, I see what happened. This here got somehow it got in the wrong place. I don't know how that happened. Just put our branch in there. Okay. Okay, so that was weird how that happened. And then let's go back up to here. So there's no errors now. Just save. Yeah, it's getting a little bit late here. We better. So we got 3 counters there that you can see those run, and we've got an internal binary bit that you can see that run. Just you know, typically you would have a lot of those in there, B3 0, B3 1, and there may be a handful of them in there doing some function before you would have a real output to come on. Okay, so we're going to download, and from there you can just go over to here and hit download. Okay, so I'm going to zoom out as you can see everything. It's going to get mighty small to see everything there. Let me just, instead of doing that, I'm going to scroll down as it runs. Okay. So when I trigger it, do you see the program? Okay.
Yeah.
So watch your B3 bit come on. It's going to function as a holding contact. And then here we go. 1, 2, 3. You do that. So you got the internal relay functioning as a holding contact now. You see that running. And so everything finished out. And do you see that the production count went to 1 here? That one went to 1. And then that one there went to 1.
Yep.
If we go over in the C5 counter section, it shows all of the counters in there, and it shows the accumulated, the presets. So now if I hit stop and do it again, then you see the counters actually going up. That one triggered, and then the next one triggered. You see how they're going up?
Yeah.
Okay. So that's how the counters look if you got multiple counters in there. So you may or may not be seeing more than one on the machine. You may only be seeing the production count at the very end of the line, But if you wanted to count strokes on a cylinder, and after so many thousands of strokes, that you would say that you would rebuild the cylinder before it really got so bad that it really damaged itself on the inside, then you may do a preventive maintenance and say, I know that it's better after 5,000 strokes of the cylinder. I know it's better to go ahead and change the seals in it than to let it run on and end up scarring the cylinder wall. You know what I'm getting at? So if it's something that's this expensive, do you guys do how many PMs like that, McGill, to where you'll rebuild cylinders after so many cycles or things like that, or?
We not necessarily. I mean, we really just go on visual and on wear.
Right.
I mean,
yeah.
But it would be something neat to put in, you know what I mean?
Right. If you got something that's super expensive that you can actually plan, and that you know that by so many strokes of running, it's a lot cheaper to just rebuild and put more seals in there to wait till they wear down and scar a real high dollar cylinder. Some cylinders are really expensive and some are just throwaway, you know.
Well, yeah. Well, we got a blade stop. It's like a bandsaw, and it's got a smart camera on it, and you're allowed so many triggers on the hammer of the brake.
Yeah.
Before you have to actually do the service on it, and it'll actually pop up on the screen after you get so many trips on the saw.
Right. That's exactly what we're saying.
So,
right. If you look here, our service light down here, you see that? Output 3. Now it's getting ready to come on. We'll do this last stroke here. So when it finishes out, the service light's going to come on, and that will just be a easy way to show you, you know. Now, actually, what I had here was I had the service light triggering off of the first counter, off of C50. So as soon as the first one triggered, it you know, and it hit when the first counter finished out, when it reached a preset of 3, then it said it was done, you know, and then this came on, and then that told you it's time to rebuild the cylinder, you know, or whatever, or the brake, whatever you're doing. So that makes sense.
Gotcha.
Okay.
Yes, sir.
So you've seen, sort of as a recap, the main 2 differences between the this 500 software and the 5000 would be the data files. The data files is where everything is stored. It's not stored in tags. There's not a tag folder. You don't see anything about tags in here. They don't have them. So when they went up to 5000, they got rid of the data files. The data files don't exist. You've got everything is tags based, and you've got a lot more flexibility on where things are stored at. So in your tag folder in the 5000, which we'll go over tomorrow, in the tag folder, you can have timers, counters, and everything can be in one folder, okay? Instead of being in separate folders. So that's one thing that they did, that you can customize your memory area can be customized. It's not clearly cut. All the timers in one area, all the counters in one area. All, you know, it's not so compartmentalized. You can actually make it look like this. I've seen engineer software writers that would go in there in Studio 5000 and create folders that look exactly like 500 style like this. And now what that tells me is that they were used to the 500 software for so many years that that's what they like. And when they got into 5000, you can go in there and actually make it look like 500 by the way you create and set up folders in there. So you can actually set up folders that have all the outputs and a folder for the inputs, a folder for all your timers, because it is a logical way to do it. And so whenever you take our class in January, this ELC 215, that's using our automation system that's on campus, you'll find out when you get in there searching through there that that's the way that guy wrote the software. He wrote the programs on that machine that way from SMC, because I can tell that he was a 500 software writer, because he's making 5000 look like 500 by the way he's actually set his stuff up. It is in 5000. But the way he's got it structured and the way it looks, he's actually got it looking a whole lot like this. Not exactly like it because there's really no data files, but he's actually created some folders in there. He's created some subroutines, I'll say that. He's created some subroutines that look like those data files, and which I thought was pretty neat. You know, you can customize 5000 and make it look like the old if you want to, and that's what some people do. So the other data files are for the N7. The N7 contains is a place that you can store large numbers like production counts. You can store large numbers like if you got chemical treatment and you got if you're storing recipes or anything like that that are involving big numbers, you can put large numbers in the N7 file. So N70 could hold an integer. It's called an integer file. And you can put a large number in N70, another large number in N71. N72, you can put a large number in each memory location in the N7 integer data file. Each position in that memory location there can contain a large number, not just a binary bit, but a large integer number, which integers are whole numbers.
Yep.
Integers are whole numbers. Now, floating point, F8, this is where your analog numbers are at. So if you have analog inputs or outputs, they're considered to be floating point, and they can be negative or positive numbers. So the F8 file is for floating point or floating decimal point numbers that are particularly analog numbers from coming in from pressure sensors, flow meters, and things like that, and output data that's going to, say, VFDs for speed control or modulating valves. So if you have anything that's stored into F8 in here, those numbers could be, for instance, like, you see this speed pot I have here in my hand? That knob I'm turning, that speed control. In F8, you could actually see an analog number on that pot changing, a floating point number changing, or you could see a sensor, a pressure sensor changing, or a flow meter, this goes measuring water flow, and things like that. So basically, F8 is for analog, basically for analog type data. That can be, that you can see negative numbers, positive numbers, and the decimal point floats around, and you can have a number like, you know, 140.99. The decimal portion, because you can have a decimal portion, it's floating point. To where integer, in the integer file, you can't have any decimal portions in there. It's all whole numbers. So if you've got whole numbers that need to be stored in your program or process, they're in the N7 file. If you have floating point that has decimal portions like 100.9 or 300.76, if you've got numbers like that, they're going to have to be in that floating point data file, and because that's the only place that allows decimal portions like that, where the decimal can be in different places. So that's a lot to chew on right there, but this information is actually in your book. It's actually in your book. The data files are mentioned in there. And I think I can tell you real quick where they are. Should be chapter 4, page 61. And I'm just going to tell you which one it is, and then we're going to close this thing out unless you got some questions.
Oh, sir.
All of the addresses that we're talking about tonight, as far as the way the addresses look, this stuff is in chapter 4. For those of you that are watching the video, or any of you, when you turn to chapter 4, it's just going to give you the gist of the address scheme for SLC 500 and MicroLogix. All that stuff is in there that you can get familiar with if you ever need it. Chapter 4 in your textbook.
All
And
right.
I think I've actually put that chapter in Moodle that you can go in there. If you don't have the book, you can download that. And let's see. The data files is also in this chapter. It's in chapter 4. Yes, sir, it is. Absolutely. Let me show you really big on the webcam what it looks like. So you'll see that everything we've covered tonight is actually sitting right in here on page 79. Page 79 covers, you see where it says data files? Output file 0, input file 1, status file 2, bit file 3, timer file 4. You see all those?
Yep.
Counter file 5, integer N7, floating point 8. Now, all of that stuff is in there. This is in your storage memory. So that stuff, all that stuff is on page 79. Now,
Okay.
I wish we'd have had time for me to lecture all this stuff. If we'd have had a 16-week class on campus, I would have been lecturing, but I can help you beyond this class. I mean, when this class ends on the 7th, this is just the end of this particular class. It's not the end of me helping you. Let's say, for instance, a week from now, or 2 weeks, or 6 months, or a year, or whenever, 2 years. If you got issues about, if you run across some of these older PLCs and you want some help, just give me a call, because this older stuff is what I worked with for like 22 years. Okay. We didn't have any of the newer Studio 5000 stuff in the plant I worked in, because that plant shut down in 2010. I mean, there was a big layoff in 2009, and at that point, the 5000 stuff was out, but we didn't have any of it. Everything we had was Micro Logix and the Slick 500s and all, and so I didn't have any exposure at all to Studio 5000 until when I came to the college to work in 2011. They knew I had a good background in PLCs, and they said, we really want to get you to go down to Rayford, the town of Rayford, and teach for Sandhills at a plant called Unilever. And they got these new PLCs in there that's using Studio 5000. And do you know anything about that? I said, no. They said, well, we're going to send you to Rockwell to learn it. And we're going to send you to these schools and get these certifications. And you learn that new software, and we want you to go down to the Rayford for Sandhills and teach it for that plant, because it's too expensive to send all those guys to Rockwell. They want an instructor to go in there from the college system to teach it, and it's going to save them a lot of money. So they sent me to 3 different level schools for Studio 5000 based controllers. And I got 3 certificates in that, level 1, 2, and 3. So I went down there and taught that stuff. So I never had a chance to work with it in them plants until I got down to Rayford. I got down to Rayford, and I got in that plant. I actually went in that plant and taught them in the plant. So I had a real good experience down there with some very, very high-tech bottling equipment that bottled shampoo and body wash and made stick deodorants, 300 pieces a minute. It was like it was unreal. It was probably the nicest plant I've ever been in. And I had a chance to go in there with what I had learned from Rockwell and figure out how to teach it to them about their equipment. So I spent a year down there at night. I drove down there for almost a year at night, teaching them that stuff. And I had to learn how to adapt it to their equipment. And I taught them guys that stuff, and it worked out good. So, but 22 years of my background was with the older stuff, you know. So I'm old school.
Familiar with it.
Huh?
You're more familiar with it.
Yeah. I had 22 years working with the old stuff, and but with the newer stuff. Now, once I got down, I went to Rockwell 3 times to get the newer training, and then I spent about a year at night in Unilever. I drove down there about 63 miles one-way trip. I rolled PLC equipment. I rolled laptops in there, set up in a training room, and then I spent time on their production floor helping them troubleshoot stuff too. So that once we hit level 2 class, it was in the springtime. they asked me to go on the floor and help them troubleshoot. So I did that. And then that's where I really helped me a lot to apply it to real machines. And so that was, it was great. It was a real blessing to get to be able to get down there and go down there. It was a long ride, but I'm glad it happened.
Right.
It worked out good. So it set me up to be able to teach you guys this stuff. And if I hadn't have done all of that, I wouldn't even know it. I wouldn't know it in depth like like what I do, because you know, I've been scuba diving in this stuff, so to speak. I've been in it. I've been way down in it. Yeah. So, yeah. It's good stuff. So, all right. So anyway, let's go back. Do y'all have any questions at all about what you saw?
Not really.
No, sir.
You know, most of the time when you're online with those with the older PLCs, it's going to be serial cable. So you would be dealing with the RS-232 driver in links, not the Ethernet driver, unless you happen to have one that somehow had that. I mean, I hadn't seen any of the older ones that had Ethernet on. Now you may see an adapter that goes from serial to Ethernet, and then they're connecting Ethernet to their network, but it would have to be through an adapter that's actually put into a control panel that actually converts it over, and you know that can be done for sure. So, but that's your main differences, guys. If you get a fault with a PLC, if you get a fault, you can go under processor status, and if you have any faults, it's going to show up. Let's see, under errors. You go into there, it's going to give you an error code in there. It's going to give you a clue as to what kind of error that it may be. And let's say if it gives you some particular error code and you don't really know, and you still feel kind of lost in there, then you take the particular error code that you have that may show up in here, and you can hit the help from right here. So when you go in the S2, as a matter of fact, when you hit that, it's S2 file for processor status, which is the same thing as this. So if you wanted to get in there, you can also get in there that way through S2 data file that's right up under the inputs, and hit errors. And let's say if you had some particular error code, you can hit the help and go under, there's a list of all your fault codes if I can find where it's at. You know, this newer version, it's not in the same place as far as all the list of all the fault codes.
Right.
But anyway, and I'm not going to keep you this about 10 o'clock. But if you, let's go back. There'll be a fault code to show up, and it's going to give you a hint to kind of what it is. You can try to clear a major error by clicking that to see if you can clear it. And if you can't clear it, then it may give you a hint that there may be something wrong with the hardware, that there may be a CPU fault. I know there's a list of fault codes. If I hit dialog box, if I go under search for fault codes, let's see if maybe I can find it that way. MicroLogic error codes. Here they are. Now, so you can search. Do y'all see what I'm looking at here, guys?
Yeah.
So for the error codes, an error code of 001, a default program was loaded. A non-user error occurs. Oh, that's it. If your memory is corrupt, it would be a fault code 3. memory module hardware fault will be a code 6. A code B would be a base hardware faulted or incompatible with operating system. So if something's wrong with the base hardware on the PLC, you might have a fault code B. If it's a fault code 12, your ladder program has a memory integrity problem. There may be something wrong with your program. Fault code 15, your user I/O configuration is invalid. In other words, you may not be telling the program the right modules that you have plugged in that you've added onto the PLC, for instance. But there's different fault codes, and there's a whole lot of them. A lot of them. It goes on and on and on and on. So there's no telling what kind of fault code you may run into. An expansion I/O module generated an error. So if you got something wrong with one of your output cards, if you've added on some modules, you might get a fault code of the 89. And it may give you a clue. It may tell you actually what slot it is, if you know what I'm saying. So I'm just showing you this so you can know that where do you find the fault codes at. You had to search for them under. I just lost that. Sorry about that.
That's all right.
Yeah, when you go under status, that's processor status, which is the same thing as if you go under here. It's the same thing. When you go under help and go under search, you can type in fault codes in there, and it will take you to the fault codes.
All right.
Okay. So
I think everybody left this one.
Yeah, that's enough. That's enough. Yeah, that's enough.
I think everybody left us.
Everybody's left. You've learned enough. You've learned a plenty for the night, honestly. So if you, if you over in the Newton Grove plant, or maybe in the plant that you're at on Five Bridge over here, if you have any PLC that's in a MicroLogic family, tonight will help you. If you have any of them that's in a SLC 500 family, the SLC 500 is one of them. Then they had the SLC 503, the SLC 504, SLC 505. It'll say SLC 5/03 or 5/04, so on. So all of those are in the family that would use the RS Logix 500 software. And the way that you go online is the same. And the way you navigate is the same.
Right.
So it's any of those are what you've seen tonight will help you on any of that. And Jamie, if you're watching this, you can ask Travis. I mean, I know Ronnie told you that what he knows of mainly over there is the 500 type controllers, but I know you got some newer stuff too, so you may have some compacts over there. Use the Studio 5000, but if you got more questions about the 500, I'll actually say this: that if you had a program you could get a copy of, and you were allowed to show me that program, if you could do a screen share and show me a program from your plant that's using this software, then I could try to help you interpret it. You could learn how to read your own programs. So I'll go as far as to say that I've done that for people before. I've done it for people at Butterball. I've done it with Victor at Smithfield. I helped him interpret one of these programs the other night that he was wondering how did it work. And he took a snapshot at work and showed it to me. And on a Saturday night, he called me. And I opened up a Zoom session on a Saturday night, man. And I went through and I helped him understand how to read that. So, you know, if we can find a convenient time to do it, I can help you learn how to read what you have. And it's
right.
You know, and I'll do it. I'll do it. And even if you have some a copy, a screenshot of some Siemens logic from Siemens PLCs.
Yeah.
I would take a crack at that because I worked with Siemens stuff years ago. I'm not sure what language you're using with it, but I would take a stab at any of it because it's all logic.
Right.
I've looked at structured text, function block. I've looked at all that stuff, and I could help you, give you some pointers on any. I would try to help you with any of it. So.
Right.
Okay, so I'll leave it at that. And if you don't have any questions, we'll go ahead and end it, Eric. You're smart.
That's fine.
For logging on like that. It's going to really pay off for you, man. It really will.
Oh yeah. Oh yeah.
Especially
I'm trying to get as much in as I can.
Every that you put into it's worth it. It really is. And you know, again, if any of you watching the recording, if you got questions about it, again, I'll be glad to help you. You just kind of get your questions together. You can ask me during a normal session or email me, and I can set up a one-on-one Zoom session and and help you with whatever you got. So I'm all into customized training. I work half of my job is curriculum with you guys, and half of it's in Con Ed with customized training. So I've done custom classes for plants before that worked out really well. We do custom classes for Butterball. I've done it for Unilever, and that was awesome one down there at Unilever. It was for the studio software, and it was on some really high-end equipment. It was I enjoyed that a lot. It was good. So I get into stuff like that, kind of seeing what's in plants. So thank you, Eric, and I love you watching.
I appreciate it.
Yep, and thank y'all for watching the recording. And again, contact me at dking@samsoncc.edu if you got questions, and I'll be glad to help. Y'all have a blessed evening, and thanks for watching. Okay.
All right, Derwood.
Get some good rest, Eric.
I will. God bless you, man.
Thank you. God bless y'all too. Thank you.